Okay guys, welcome back. Let's talk today a little bit about basic gas laws. There are 4 basic gas laws that help us understand the basic behavior of gases. Boyles Law, Charles' Law, Avogadro's Law, and Monstrance Law. A quick reminder, when we work with gas laws, we must convert all over temperatures to degrees Kelvin. Let's start with Boyles Law. Boyles Law tells us that pressure and volume of gases are inversely related when temperature and number of moles remains constant. Since they are inversely related, we can see that as pressure is increased, the volume decreases, and the opposite is also true. As pressure decreases, volume increases. This is denoted by the equation P1 V1 equals P2 V2, which means it's equal to the product of the final pressure and volume of the same gas. Just as it was with M1 V1 equals M2 V2, the species of your gases must be identical. If it changes, then your moles are not constant and you are not able to use Boyles Law for that problem. Let's do a quick Boyles Law problem. A flexible container of oxygen holds exactly 57.3 milliliters with a pressure of 6.22 atm. If the pressure of the oxygen gas is reduced to 1.83 atm and if the temperature is held constant, what is the new volume of the oxygen gas? Once again, you can solve this problem in the same manner that you did M1 V1 equals M2 V2. Since we're trying to find the final volume, all we have to do is divide the initial pressure and volume by the final volume, which results in 0.195 liters of oxygen. Let's move on to Charles' Law. Charles' Law tells us that volume and temperature of gases are directly related when pressure and number of moles remain constant. This means that as the volume increases, so does the temperature, and as the volume decreases, so does the temperature. This can be denoted by the equation V1 over T1 equals V2 over T2. We will work a problem similar to this one later on, so you have an idea of how it works. In the meantime, let's move on to Avogadro's Law, which tells us that the volume and number of moles of gases are directly related when pressure and temperature remain constant. Just as in the case of Charles' Law, when volume is increased in Avogadro's Law, so does the number of moles. As the volume increases, the number of moles also increases. The opposite is true. As the volume decreases, the number of moles also decrease. This may be denoted by the equation V1 over N1 equals V2 over N2. As I mentioned before, let's go through one of this type of problems so you can see how they work. A 0.225 mole sample of helium has a volume of 6.54 liters. How many moles must be added to give 8.46 liters? In this case, we must shift our equation a little bit. N2 equals V2 times N1 over V1. So as you can see in this problem, our equation is final moles equals 8.46 liter, which is our final volume, times 0.225 moles, which is our initial moles, divided by 6.54 liters, which is our initial volume. Our final number of moles is 0.291. However, this problem is asking us how many moles must we add. So we subtract our initial moles from the final number of moles, which results in 0.036 moles. So let's go through our final law, which is a Monstrance Law. It tells us that pressure and temperature of gases are directly related when volume and number of moles remain constant. That means that as the pressure increases, so does the temperature, and as the pressure decreases, so does the temperature. This is denoted by the equation P1 over T1 equals P2 over T2. As you may have noticed, a Monstrance Law, Avogadro's Law, and Charles' Law work similar to each other. The problems can be solved in the same manner from one to the other, while Boyles' Law is similar to M1 V1.